Okay, so now you have your channel, you have your idea, you know which channel size you need to do, which flow rate you need to pass. And now let's go to the fabrication, which usually is called, if you want to search more for it, it's called BioMEMS, which mechanical systems fabrications. Okay, so you have your channel design, right? You design this part. Now, why would this be the inlet and why would this be the outlet? Now, does anyone know what is the size of dust particles? The dust particles range between 1 micron to 100 micron. Now, imagine if you have a channel of a 50 micron or even 100 micron. These dust particles can go through your channel and block your channel. And this is one of the major ways of why, oh yes. Mm-hmm.
Oh, I was just gonna say why I think the outlet would be the outlet, because the main reason I thought that that would be the outlet was because it's not it's circular, and when we are working with cells, we don't really like. I don't know, maybe this was like a different kind of idea, but I was thinking that we don't want too much of corners because it makes it harder.
Yeah, definitely. That's actually a great input. So we want actually the outlet to be round so the flow just can go in without forming vortices or forming some sort of a secondary flow at the outlet. Is that what you meant?
Yeah.
Awesome. Yeah, that's true. And in the inlet, you really want to have filters in this way because you want to catch dust particles in the beginning. As you can see, dust range between 1 micron to 100 micron in diameter, and you want to really catch them before they go into the channel. And this is why usually you put filters in the beginning of whatever application you want to do here. This is the right way of designing your inlet and outlet. And usually you do that by Autodesk, AutoCAD. You design this and then you send it to a company so they can print it in a transparent sheet. You get it in a FedEx, and then you start the real work, which is you go to the clean room. Now, they call it the clean room because they already have filters in their air system that prevent dust from coming in the clean room. And I remember my friend in Berkeley, when the pollution or the fire thing happened, everyone wanted to go and work in the clean room because of the pollution at that time and the fire. But it's really the reason why that you don't want dust to go inside your devices, especially when you're fabricating a device that is already 20 or 50 micrometer in diameter. Whatever dust comes in this process is just gonna ruin your channel. Okay, so how then basically you can use this mask? So you already got your mask to use soft photolithography. And the first thing you do is you got your wafer, you pour a negative photoresist, and then you spin it. So you have one layer, which is, you guys see this brown thing here or orange? This is your photoresist or your negative photoresist. So you got your negative photoresist, then you put the mask on top of it, and then you shine UV. Now, when you shine UV, whatever is exposed here, which is the white thing, right? This is the transparent part, is gonna be insoluble. And then basically you can wash over the other parts that was not exposed to UV, and then you get your channels. And this is how you can imagine this as seeing it as in a cross section. I saw a raised hand or a chat. The yellow.
So
Yeah.
Alex has a question about the yellow light in that clean room.
Oh yeah, so the yellow light is just to prevent the UV and other source of lights, right? Because if we put these materials out and there's UV light, then basically you would get, or other source of light, all of your chemicals will be ruined, really. So you have to have a yellow light just not to expose your samples, because all this is done by UV. So so this is the only reason. Does that answer your question? Give me a thumbs up, or I can't see anything, but cool. Yes, awesome. Okay, so now let's move in Now you got your wafer. Now you go back to your lab. Now, in your lab, you already have your lab setting. You don't need to go back to the clean room. You go on and pour PDMS, which is basically a polymer that when you mix it with a curing agent, with time you get silicon cross-linking, and then basically you can peel this polymer out of your channel and you can make 1 million of them, right? Once you make the channels, then you can punch holes and you get your inlet and outlet, right? And then you bond it to a cover slide or a cover slip, and then you do your experiments, which is kind of what you see here. Awesome. Okay. Yes, someone wants to unmute it there.
Question? Yeah,
Yeah.
I have a question. Would you, if you go back to the slide before you pour the PDMS in it, would you autoclave the sold paper developers?
Yeah, you can definitely autoclave because these can handle a temperature. So autoclave means 100 Celsius.
Mm-hmm.
Yeah.
Because I know that UV doesn't kill everything, especially like mold, for example, too.
Mm-hmm.
I don't know if that would be a thing, but
yeah, that's a great point. Especially if you want to use it with cells, right? So you definitely want to autoclave it. And some people clean so usually what people do, if you want to use this in your devices, once you bond your device, once you put it inside, once you punch holes and everything, also you put channels, tubing, you go and put everything in the autoclave, and then you seal it and you get it out. So this is the way to do it. Mm-hmm. Okay, because you have to bond and punch holes everything outside the autoclave, so it's better just to be done with everything. So this is the right way. Cool. So I'm gonna stop now for 1 minute or less if anyone have any questions until now. Also, I want to check on the time.